Thank you. Once again, welcome.
Jeśli chodzi o układ tej prezentacji, trochę wprowadzenia.
A few words of introduction to the presentation. I'll start with that, then there will be some basic discussion of road safety barriers and how they function. Then I'll describe the field crash tests. This very well corresponds with the previous presentation. In order to be able to run numerical analysis, we have to always run appropriate field tests. So there will be some selected results from the field crash tests. And finally, I'll discuss how those results can be translated into the principles of using road guardrails. What was said before by Professor Witkowski indicates that the investigations of the barriers of the guardrails was done under two separate RID projects. One was for road safety equipment, and the other one concerned the effects of time and operating conditions on the functionality of the same road safety equipment. And now, what are the problems that we face? When we look at road guardrails, we're talking about safety in the vicinity of road and heavy traffic. Talking about what Professor Gaca discussed, we always have to use guardrails in order to protect persons in the vehicle from what's outside the road? But also, we need to design roads in such a way that we do not need guardrails. If there is no other way, of course, we should use guardrails.
Bardzo często niestety jeszcze ciągle występują na naszej sieci drogowej. Na mapce widać
on the map you can see
udział procentowy
the share in percentage of lethal accidents by region, by voivodeship. This usually is related to trees that grow close to the road shoulder, but also other factors.
Tych wypadków, które są związane z otoczeniem dróg, praktycznie zaraz obok zderzeń czołowych.
You can see that the next thing to head-on collisions is falling off the road on a curve. The severity of these accidents is usually very high. When we originally started doing the research under those two projects that were dedicated to road barriers, we found that there was a need for some tools for designers and also people who maintain safety infrastructure. We're lacking tools that would allow us to evaluate the consequences of collisions with those elements for safety. Also, we needed tools to evaluate how these safety measures affect the behavior of vehicles at impact. Also, we would need tools that will allow us to evaluate whether those safety measures maintain their functionality. Now, if we impose certain requirements and we expect certain features from road safety barriers, then the key issue is the functionality, so the usability of these devices. It must be functional at all times, and this is of key importance. We need to ensure continuity of operations of these elements of infrastructure, and this functionality is defined by safety, reliability, effectiveness, ability to keep the vehicle, maintain the vehicle and redirect it. The effectiveness has to be also economic.
jak również wpływ na środowisko.
Also, it should not impact
Jeśli
the
chodzi
environment in a
o
negative way.
teoretyczne podstawy
When we look at the theoretical
funkcjonowania barier w
basis for the
momencie, kiedy
functioning of the
dochodzi
barriers,
do uderzenia,
when
to opiera się
there is
tutaj
impact,
głównie na energii
there's a
kinetycznej,
crash, it all
jaką,
is based on the
pojazd
kinetic
uderza,
energy
barierę.
at
No i ta
impact.
zależność właśnie, gdzie ta energia
So,
zależy od masy
the
uderzającego
kinetic
pojazdu,
energy will
kąta
obviously
uderzenia
depend
i
on the mass of the weight of the
prędkości, z jaką
vehicle,
to
the angle of
uderzenie,
impact, and the velocity.
z jaką doszło do tego uderzenia. I teraz
Now,
przechodząc już do
moving
testów
on
poligonowych,
to
na tym slajdzie mogą
field
Państwo
tests.
zauważyć, jakie
In this
typy
slide, we
testów
can see the
są
types of
przeprowadzane.
field tests that are
Jest to
carried out.
jednocześnie pokazane wraz
This is
z
also
pojazdami, które
shown
są
here
używane
with
do
the
danego
types of
testu,
vehicles that
jakie
were
są
used for these
podstawowe parametry
tests. So you can
takich
see the
testów
basic
uderzenia,
parameters that were
uderzenia
taken for the tests:
i,
velocity,
jak to przekłada
angle,
się
and
na
weight.
poziomy
And you can see how
powstrzymywania
this
barier,
translates into the
w dużym
containment
skrócie można
levels.
powiedzieć, parametr
Speaking
określający,
very briefly,
jakie pojazdy
this is the
dane
parameter
urządzenie
which
jest w stanie
says what sort of
powstrzymać.
vehicles this device can
Testy
maintain on the road.
poligonowe, które były realizowane
tests
w ramach
that we carried out
projektu, można podzielić
during
na
the
testy
project can be
niestandardowe,
divided
czyli
into
takie,
non-standard,
które nie były
namely
zgodne z
such that
normą
were not
1317,
consistent
z tego
with
powodu,
the
że
standard
były wkładane trochę
1317.
inne elementy,
And that's
te,
because
które
what we tested
mogły nie
were
być
slightly
wcześniej,
different elements, such that were not
ale również
recognized
były
earlier.
tutaj realizowane
But we also
testy standardowe.
carried
Mamy
out standard
przykłady
tests. We have here some examples from 3 field tests that took place on 3 different dates. There was a steel barrier, rope barrier, and a concrete barrier. Looking at the detailed analysis of the selected tests, 9 of the tests that were carried out under the 3A segment of the project. In the picture we see just 6 of them because 3 of those tests were implemented as repeat tests. It's the situation that was discussed in the previous presentation. What was done in those 3 tests was that there was a second impact into a damaged barrier. So we tested rope barriers, steel barriers, and concrete barriers. These were located on a curve without any inclination. There were connections between a wire rope barrier and steel barrier. There was a test with a short bridge barrier. That's one of those tests with a lightweight vehicle, where we mainly tested G force inside the vehicle. And we hit the same barrier later with a bus. And a very interesting test, we put in a lighting post in the barrier, and as a result, as you can see, the safety measure of the barrier, that is the bottom right picture, did not work properly. These are the tests, that were carried out as part of the project, and based on these tests, reports were made. And from those reports, you could gather a lot of information about how the device behaved, how the vehicle behaved after hitting the barrier, and we also looked at the various parameters that really determine the functionality of the barrier. So dynamic displacement, the depth of damage, the number of damaged posts, segments that needed replacing. We also looked at the severity of the incidents,
oczywiście była sporządzana
ASI and
dokumentacja,
THIV. And of course, we compiled photographic and video documentation.
Przechodząc do już
Now, moving on to the analysis of the
wyników
results
badań poligonowych, testów zderzeniowych,
of the field tests, of the actual crash tests.
taki podstawowy cel tych badań
The
to
main goal
określenie
of
pewnych
those tests
potrzeb,
was to define
które są
certain
związane
needs
z
that are
projektowaniem
related to
i
designing
barier,
and using
żeby określić,
road barriers
jaki jest wpływ uderzenia
in order to
pojazdów w
determine the
bariery,
effect of an
jak
impact
to
of a
wpływa
vehicle
na,
on the barrier. So
konstrukcję tej bariery
how does that
i na jej
affect the
parametry
structure of the barrier
użytkowe.
and its
Tutaj
further
postawiono dwa takie pytania badawcze. Pierwsze pytanie, jakie
functional
czynniki
parameters?
związane
We
z
asked
ruchem
two
pojazdu
questions.
mają
What
istotny
factors
wpływ na
involve the
parametry
vehicle movement
funkcyjne?
in the vehicle
Te,
movement had a
które
significant
definiują
effect on
właśnie
those design
deformacje
parameters
czy uszkodzenie
that define
bariery,
barrier
jak
deformation or
zmieniają
damage?
parametry
And therefore,
funkcjonalne
how do
barier.
they change
Wreszcie,
the
czy
barrier
można
functional parameters? And the
opracować
second
proste
question
modele
is,
matematyczne,
can
które pozwolą
simple
na
mathematical models be
szacowanie
developed that will
wpływu
allow us to
parametrów
easily
pojazdów
estimate
na
the effects of
uszkodzenia,
vehicle movement
uszkodzenia
parameters
barier.
on the type of damage
Tutaj
and functionality of
kilka
barriers?
takich wybranych
And here are some of the
parametrów,
selected
funkcjonalnych
parameters,
barier, które były
functional parameters of the
analizowane.
barriers that we analyzed.
Wspomniana już energia kinetyczna, to jest ten
First was the lateral
podstawowy
kinetic
czynnik,
energy and how it
również odkształcenie
affected
barier,
barrier deflection,
odporność na to odkształcenie,
deflection performance,
sztywność
so resistance to
konstrukcji
deflection,
zdefiniowana
barrier design
wzorem,
stiffness, here defined
gdzie
with
występuje masa
formula
pojazdu,
in which you have the
prędkość,
weight of the
kąt i,
vehicle,
odkształcenie
velocity,
dynamiczne.
angle and
I
dynamic
również
deflection.
analiza,
Also, you have the
wskaźnika,
analysis of the
ciężkości czy intensywności
severity
uderzenia.
level
Bardzo
of the
istotny,
impact. This is
parametr,
a very
te
important
urządzenia,
parameter
które
because the
nie
devices
uzyskują
which do
odpowiednich
not
wartości tego parametru nie mogą być dopuszczone do
the required value of that parameter cannot be permitted to be used because they constitute too much hazard for the persons
Tutaj
inside the
mamy
vehicle.
przykład analizy
Here's an example of
dotyczącej
an analysis
odkształcenia
looking at
dynamicznego.
dynamic deflection.
To odkształcenie dynamiczne, ona charakteryzuje pracę
It,
bariery w trakcie
characterizes
uderzenia pojazdu.
what the barrier does on
Opracowano
impact.
zależność,
There's a relation defined here, so what does dynamic deflection depend on? So that would be barrier stiffness, lateral kinetic energy, and vehicle mass. And you can see that dynamic deflection increases as lateral kinetic energy increases, and it decreases as barrier stiffness and vehicle mass increase.
Kolejny parametr funkcjonalny
Next
to szerokość pracująca bariery.
Barrier working
To
width,
jest parametr, który charakteryzuje sztywność, podatność
which
bariery
really
na
characterizes barrier
pojazdu, również
stiffness
opracowana
or its
zależność
flexibility to
od,
vehicle impacts. And
odkształcenia
again,
dynamicznego
we've
i
defined
od szerokości
the relation
bariery i
between
właśnie szerokość
barrier
pracująca
width and
rośnie
dynamic deflection, and so
ze
working
wzrostem
width
ujęcia
increases
dynamicznego
as dynamic
i
deflection goes
szerokości
up, as
bariery.
well as barrier
No i
width.
wreszcie
And finally,
poziom ciężkości,
the severity
ASI,
level, which is
tutaj jego
the
zależność
ASI,
od energii
ASI
kinetycznej poprzecznej,
indicator
od odkształcenia
and its relation
dynamicznego.
between
ASI
lateral
rośnie wraz ze
kinetic
wzrostem
energy and
sztywności,
dynamic deflection. So
bariery.
ASI increases
To,
as
tak jak mówiłem
barrier
wcześniej,
stiffness
to
increases.
istotny,
And this is
istotny
a
parametr.
crucial point here.
Jak te wyniki, oczywiście ja tutaj tylko przedstawiam
So what
pewne
I'm
wyrywkowe
presenting you
wyniki, ale jak te
is just
wyniki,
bits and pieces of the
wpłynęły na
results.
formułowanie
But
przepisów
how did we use the
dotyczących
results to
projektowania?
formulate
Do końca.
regulations?
Tutaj mamy przykład, w jaki sposób powinna
Here's an
być
example
dobierana minimalna
how
szerokość pracująca,
We should
która
define minimum
jest
working
zdefiniowana właśnie przez ujęcie dynamiczne
which
i
is defined via
szerokość,
dynamic deflection
szerokość samej
and the
bariery.
width of the
I
barrier.
również kwestia związana z
And there's
tym,
another
jak w
thing
sposób
here,
powinny być dobierane
which is how we
poziomy
should
powstrzymywania barier. Tutaj
identify
jest to
or
określone na
pick
podstawie
containment
ryzyka
levels.
przebicia
This is
bariery
based
drogowej
on the risk of the safety barrier being penetrated.
Przebicia bariery
You can see some photographs of that here. And in the table below, you can see how containment levels should be defined, and that depends on the expected consequences of accidents, roadside accidents, and that in relation to road class and volume of heavy traffic. So finally, the study was based on crash tests, and then we added numerical studies to complement the work. And what we know based on this is that it really makes sense to study these elements because the severity index increases as barrier stiffness increases. And working with dynamic deflection depend on barrier stiffness and kinetic energy. So these are the findings. One other finding is that the field crash tests are really key because that way we can study or understand the basic parameters. But obviously crash tests cannot possibly cover everything, and so we need to expand the analyses by adding numerical studies, giving us a much broader view of how a barrier operates on impact. Thank you.